Hi, welcome back. So we are in Chapter 3, Descriptive Analysis on the Distribution section, and that is to discuss the first kind of distribution, the form of mass. We've discussed earlier having a variable x, and if the scalar happens to be in the form of nominal, ordinal, or discrete, it will be fallen under the mass kind of distribution. So let's go ahead, try to explore visual presentation on the case of mass distribution. Let's assume that we have this variable x with two possible outcomes. Case to be green or to be red, just for illustration purpose. This kind of outcome, when it has only two possible outcomes, we call it dichotomic. If you would have a sample of subjects. Now, the first thing you might want to do is a table. What are the possible outcomes? Could have green, could have red. And according to my counting here, I have 2 greens, 4 red. The sample size of n should be equal to 6, which is distributed as 2 green and 4 red. To graph this as follows. I could create, for example, x-axis, it take the possible outcome. I know that I have possible of green, and I know that I have possible of red color. And on the y-axis, state down numbers. It could be in hundreds, in tenths, doesn't really matter, but I'm going to follow the normal scale of 1, 2. So according to my table, I see here that 2 happens to be green, 4 happen to be red. This kind of a graph, we call it bar graph. I can take the percent of this green on the total of 6, which is 2 over 6, 1/3. And I know that 4 over 6 come to 2/3. And as you guess correct, that the sum of these percentage must come to 1. And I can graph it as well. And something looks like so. For example, I can draw a circle. This kind of a graph, it's called a pie graph. I think the name is quite indicative. This is the possible way to explore the distribution of this vector on this variable x. The same is sustained, nothing would change if the variable x happened to be more than 2 outcomes. For example, A, B, C, D, whatever you like. The same thing, you may create your own table following the same exact thing. And then you give the number of the distribution. Maybe you get the percentage as well. What is the percentage for each one of these possible outcomes? Of course, the graphing, it will be exactly the same where you have the A, the B, the C, and the D. What are the bar distribution on them? You can also create the percentage pi. These are the possible way of learning about the distribution of a certain variable, like this vector, using either table format or graph format. Sometimes you might end up by creating more customized kind of a graph, if you like. That was the illustration on mass distribution when your scalar happens to be a discrete, either categorical nominal, ordinal, or numerical discrete. Next, we will be looking at the density distribution when my scalar happens to be continuous. I will see you then.